Alrighty, in today's topic, we're going to be talking about 5.1 transformations of functions. All right, so the big thing is everything kind of stems from the same thing. So I'm going to kind of put it all together rather than separating each thing. But I'll write it out pretty big. So all of your functions, let's call it h of x in this situation, all comes down to this: a times some function of bx minus h plus k. Everything stems from this. So to kind of break this down, A deals with reflection over the x-axis. It also deals with your vertical, not shift, stretching and compression. So again, it breaks it down each individual thing, but I just think it just seems better just to see it all at once. All right, and so then if A is greater than 1, technically the absolute value of A is greater than 1, it will be a stretch. And if A is between 0 and 1, it will be a compression, vertical compression. This right here just represents whatever the function is. So this could be a quadratic, could be a radical, could be a rational function. It doesn't really matter. It's whatever the function is. Then you have your B, which basically deals with reflection over the y-axis and deals with horizontal stretching and shrinking, or compression, sorry. You see compression shrink a lot in different books. This one uses compressions. Stretch, though, for horizontal will be between 0 and 1, and a horizontal compression is actually when the absolute value of B is greater than 1. All right. Then we have our H. This deals with our shifts left and right, but does the opposite of what you think. So if I'm going left, I'm actually adding, and if I'm going right, I'm actually subtracting. And then the last one here, your K, deals with shifts up and down, where it does exactly what you think it would do. So if I'm adding, I'm going up. If I'm subtracting, I'm going down. And this is pretty much the exact same transformations for every single different one. It just might look different, but it has the same characteristics. So I want to make sure I got it all. So I got the horizontal, got the reflection, got the vertical shifts, got the stretching for compression of vertical. And then horizontal. Other thing too to note when you're trying to determine the factor of a horizontal, so the factor will always be 1 over B. So whatever, oh, sorry, absolute value of B. But whatever the B is, instead, like for vertical, the factor is what it is A. So if A was 2, then I'm vertically stretching by a factor of 2. But if my B is 2, I'm horizontally compressing by a factor of 1/2. So that's kind of the difference there on the factor part. And another big thing to note as well is what is the order to best graph these? So the order, that's not a order of transformations. The first thing you want to deal with is your horizontal shifts. So that will be your, I guess I should have wrote those. But this right here would be horizontal because it goes left and right. And this is vertical because it goes up and down. So that deals with your left and right. So that's the first thing you deal with. Then the second thing you want to deal with is horizontal and vertical stretching and compression. So horizontal, vertical, compressions, and stretchings, whatever it might be done. And of course, you can have multiple things going on here. The third thing you want to then graph is any reflections. So that's simply just looking at your A and B. It can be X or Y axis. And then the last thing will just be dealing with whatever your vertical shifts are. So then I'll move the graph up and down at that point. See, I think that highlights everything. It does. All right. So that's pretty much the entire section right there on a nice, clean one formula thing. So you don't got to look at 15 different little tabs. That's all right in one spot. So this would be definitely a good one to definitely note of. So in the your homework, I believe it does mostly of just you like figuring out what like the parent function basically came from, and then describing the transformation, and then given the transformation, then graphing it. So that's kind of what I'm going to do here. So we're going to be on page 321. I love that 321. And we're going to look at number 2. So number 2 says f of x equals 1 over x minus 4 plus 5. So again, it says for each function or graph below, determine the basic function. Basic meaning the parent function. So the first thing I need to do is determine the parent function. And I'm just going to call it f of x. I think it calls it like something else, g of x or whatever. And basically, if you got rid of all the numbers, what would you be left with? Now, in this case, this 1 is part of the function, but this minus 4 and this plus 5 is extra. So what I like to teach my students, especially in high school as well, is I'll circle everything that looks to be extra. And I can see that I'm left with 1 over x. So 1 over x would be my basic function that has either been shifted, reflected, stretched, or compressed. So that's really all you had to do on the first ones, but on the homework, it then also wants you to describe the transformations. So that's what I'm going to do here as well. So it doesn't matter which one you describe first. I just read a graph from left to right. So I'm going to deal with this minus 4. So this minus 4 would be as if it was in parentheses. So I can kind of rewrite this so you can see, but this is the same thing as x minus 4 to the negative 1 power. Because remember, this is written as x to the negative 1 as well. So that minus 4 is being done inside the parentheses. So if it's inside the parentheses, this tells me it's a horizontal shift. And then you do the opposite of what you think. So when you think minus 4, you think you're going left, but you're actually going right 4 units. And so then the next thing is I'm going to deal with that plus 5. So that's going to be a vertical shift. So a vertical shift deals with up and down and does what you think it's going to do. So I'm going to go up 5. And so again, in the book, it doesn't make you do this, but on your homework, it does. All right, so let's do another one. Let's look at number 9. Number 9 says f of x equals x plus 6 cubed. Again, I'm going to circle what I think is important here, or different, which is the plus 6. So that means that my parent function is going to be f of x equal to x cubed. So that tells me that's a cubic parent function. So then the second thing is that this plus 6 is being done inside the parentheses. So that's going to be a horizontal shift 6 units to the left. Does the opposite of what you think. All right. Let's see what else we got. All right, so let's look on. Let's look at number 16. On this one, it says sketch the graph of the following functions by first identifying the more basic function. They have been shifted, reflected, stretched, or compressed. Then determine the domain and range of the function. All right, so graph, I'm just going to sketch the graph. You'll have the ability to like pick some points and stuff like that based off of things. You'll get to just move the parent function around. But on number 16, we have f of x equals x plus 2 cubed. So in this situation, my parent function that plus 2 is the only thing that's extra, would be f of x equals x cubed. So that's my parent function. And so then this plus 2 tells me I'm horizontal shift to this done inside the parentheses. And again, I'm going to do the opposite of what I see. So I'm going to go left 2. So knowing that the parent function of a cubic looks like this, I'm going to take that origin and I'm going to move it over 2. So here is my best sketch without technology. So here we go. There's my 2 to the left. And I think I'm going to do something like that. So give or take, that's what your function would look like. Now, of course, you have an inspire, so you're able to graph it and then compare some good points by all means. I just want to make sure you understand this just in case you do have a professor that doesn't allow the calculator. All right, so then my next one, we'll look at number 17. 17 says g of x equals the absolute value of x minus 4. And it wouldn't be a good lecture if I didn't have some technology issues. So give me a second. All right, much better. All right, so in this case, my parent function let's see. So the only thing I see that's different is this minus 4. So that means that my parent function must be the absolute value of x, which I now know looks like this right here, based off our previous lectures. And so then I look at it, it's being done inside the parentheses. So that tells me this is a horizontal shift. And again, we do the opposite. So this would be right 4. Right. So then I take that center right there, and I'm gonna go right 4 with it. So 1, 2, 3, 4. Give or take, that is what your new graph looks like. All right. Let's look at number 19. Number 19 says g of x equals the square root of x plus 3 minus 1. Again, I'm gonna look at the parent function. So here's my plus 3 and my minus 1. Everything else looks like it would be originally the parent. So that means that I'm left with the square root of x. So that means I have a radical function that looks something like this. So then I go, all right, the plus 3 happened inside the square root. So that's the same thing as the parentheses. So it's going to be a horizontal shift of left 3 units. And this -1 is a vertical shift, and it does what you think, so it'd go down 1 unit. So given that information, I'm going to take go left 3 and down 1. So, ooh, probably too much dramatic. So I'm thinking that right there would be what my new function would look like. All right, let's look at number 27. Number 27 says k of x equals the square root of -x plus 2. So I need to think about what my parent function looks like. And I see I have a negative here and a plus 2. So my parent function must be the square root of x. So I'm back to my radical. But this negative, if you recall from the notes, deals with the reflection. And if the negative's inside the parentheses, it will be a reflection over the y-axis. And then this plus 2 would be a vertical shift of 2 units up, because it does what you think. So again, to graph this, I got to follow those 4 steps. So the first thing I need to do is horizontal shifts, which I don't have any, stretching and compression, which I don't have, reflection, so I do have it. So my reflection over the y-axis would look like this, and then I'm then going to do a vertical shift up. So here's my vertical shift, and then I have a function like this. So originally it reflected over the y-axis, and then I shift up. So this is what I want to look like. So I will say a lot of times people will try to take this, shift up, and then reflect over the y-axis. So then it'll look way over here, but don't make that mistake. And I did make a mistake because I said reflect over the y-axis, and I'm over here reflecting on the x-axis. So if I reflect over the y-axis, I'm going this way, and then I'll go up 2. So there you go. So make sure you're reflecting over the right axis there. And I completely forgot we were supposed to be doing the domain and range of these guys. So let's backtrack on that. The domain of this, I can see for domain and range, there's no restrictions for a polynomial function. So the domain and range, yeah, so they are good with the all real number symbol. This right here, the domain is all real numbers, but the range does have a restriction. It starts at 0 and then goes to infinity. So the 0 be included, and then infinity is where it's heading. And then number 19, I can kind of look at this one here. I can see the domain has a restriction of the farthest left number being -3 all the way to infinity. So parentheses, and the number gets a bracket that's included. The range goes from -1 to infinity as well. So there's my domain and range. Same concept over here. My domain looks like it's negative infinity at first and then stops at 0. So the 0 is included. And then my range looks like it starts at 2 and then goes up to positive infinity. So you basically just see what so again, remember domain is left to right and range is bottom to top. So I look at the farthest left number to the farthest right, bottom number all the way to the top number. All right. So, phew, almost forgot all that. So let's now look at let's look at number 30. Number 30 says R of X equals 4 minus 2 to the power of x. When I look at this, I can see that 4 and -2 is the extra, but I can also see it's not quite written the same way I would have written it. So I'm going to write it so that the function comes first, and then the things I'm adding or subtracting comes last. That will help me know that that +4 is actually a vertical shift. My parent function, I can tell it's just going to be the absolute value of x. So we have something like this. So I see now in this case, there's a negative on the outside. So there is a reflection over the x-axis. And then I see that because there's a 2 on the outside, there is a vertical. either a stretch or a compression. So you got to remember if it's greater than 1 for A, it's going to be a vertical stretch. What I always kind of help myself remember is anything outside parentheses is vertical, and it does what you think it would do. Anything inside the parentheses is horizontal, and it does the complete opposite of what you think it would do. So this is a vertical stretch by a factor of 2. So that takes care of those two things. And then I have the plus 4. So this is going to be a vertical shift up 4 units. All right, so I'm going to use all those facts. And again, I can see that I have to do any horizontal shifts, which I do not. Horizontal and vertical stretching. So I have a stretch of a vector of 2. So originally this is like 1, 1. So what you do is you just multiply it by 2. So that 1 would now be the value of 2. So I would like, this would be my new point rather than here because it's being stretched vertically. And then reflection. I do have a reflection over the x-axis, so it'll be skinny. And then vertical shifts. So then I'd go up 4. So here's where I will start. So I would typically go over 1, up 1, but I have to multiply by 2. So I'd go over 1, up 2. But because I'm reflecting, I'm really going to go over 1, down 2 to this part right here. Over 1, down, over 1, down 2 right here. And the same concept here, over 1, down 2, over 1, down 2. So I get a more accurate absolute value function of something like this, just using that information. So with absolute values, -2 there is kind of like the slope there to start you off, and then the other side reflects. So that means going down 2 over 1. You're going to remember it. And then again, I did that vertical shift up last. So there is my graph result. And then from that, I just need to pull the domain. So the domain again goes from left to right. So that's going to be all real numbers. And my range goes bottom to top. So I'm going towards negative infinity at first, and then I stop at 4. All right. So there's that one. Let's look at number 32. All right, so 32 is g of x equal to -1 over x plus 1. And so looking at it, I only have a couple of things. There's like a negative here and a plus 1 here. So my parent function looks like it would be 1 over x. So that's going to be my rational function. So 1 over x does this with the branches. And then I can see that negative on the outside would be a reflection over the x-axis. The plus 1 deals because it's inside the function. So that would be a horizontal shift, and it does the opposite. So you think you're going right, but you're really going left 1 unit. So again, going with the steps on how to graph it, I start with my horizontal shift. So think of it like this. I'll help you out. We haven't gotten to this point, but there's like imaginary. That's not a good color. Green. Here we go. So there's like an imaginary line right here that's called the vertical asymptote that the graph cannot graph over for certain situations. We'll get to this more specifically. So what I want to do is I want to shift it left 1 unit. So now I want this vertical asymptote to be here. And then this will be where my new branches will be. So that's my, and then I got to reflect that over the x-axis. So now my branches are on this side right here. And then I'm also horizontally shifting. Oh, I already did that. Did the horizontal shift. Then I did with the reflection. So now my graph was originally here, reflects over, originally here, reflects over. So there you go. There's what you also can't see is there's like an imaginary a horizontal asymptote there as well, and that would deal with a vertical shift if you had one. Right. So that's basically how that graph would look on number 32. And then with that, talking about the domains for rationals are basically like what can x not be to put 0 at the bottom? And in this situation, x can't be -1. So you go, all right, x can be everything except -1. So that's why we have parentheses around the -1. It's including everything except that value. And then for range, what does that cause x to not, or y not to be able to be? I can see that y can never be 0. So that would be the same concept. It would be everything but what y can't be. And that's going to be your vertical shift, basically. So in this case, 0 is what it can't be. So that's a good introduction to our rational functions, and we'll get into more details in a later chapter on that. All right, let's see what else I got. That was number 32. Let's look at number 33. 33 is h of x equal to x squared divided by 2 minus 3. Again, looking at the parent function, I can see the 2 and the minus 3. So that's going to be f of x equals to x squared. So that's going to be my quadratic function. I can see the 2 on the outside is actually, if you kind of rewrote this, would be something like this. So it's technically a 1/2. So this would be a vertical compression, and it's a compression because the a is less than 1, and it'd be by a factor of 1/2. And then the minus 3 is a vertical shift down 3. So when I'm graphing this, it's originally what it is, and then it's a shift down, and then I'm going to compress that by a half. So that means I would typically go over 1, up 1, and then over 2, up 4, because you're squaring it each time, but I need to half that. So instead of going over 1, up 1, I need to go over 1, half of 1. Or I can say go over 2, up 2, because it would not be 4 anymore. So in this case, I can then map that out because quadratics are symmetrical. And I now have a graph that looks something like this. Right? So kind of using those details from the original function. All right, let's look at number 41. 41 is g of x equal to negative parentheses 3x plus 3 cubed. And again, I can see that the negative, a 3, and a 3 are all extra. So my parent function would be f of x equal to x cubed. So I have a cubic again. So this is what I'm looking at. I see that negative on the outside of the parentheses. So that's going to be a reflection over the x-axis. I see a 3, so that's going to be a horizontal because it's inside the parentheses. And you would think it's going to be a stretch because it's greater than 1. So it does the opposite. So it's actually a compression. And you would think it's going to be 3, but remember it has to be by a factor of 1 over what you think it's going to be. So in this case, factor of 1/3. Then the minus or the plus 3 here is going to be a horizontal because it's being done inside the parentheses. So it's horizontal shift. And again, you think it's going to go up 3, but then it actually goes down 3. So it always does the opposite of what you think inside. So kind of working this out. Again, to go through all the steps, horizontal shifting first. So that went down 3. So here I am here. And that not down 3. That should have been left 3. So I'll go 1, 2, 3. So I'm actually over here. And then my stretching, so it's going to basically be a third. It's going to be kind of harder to draw out later. Then my reflection over the x-axis, so then it's going to look like this. And then no shifts, so there's no vertical shift. So I'm basically right here. And then I'm going to draw it like this, but be a factor of 1/3. So if I would go, typically I would go over 1, up 1. But in this case, because that's what 1 cubed is, I would have to go over 1, down a third. So that'd be kind of maybe like this right here. Go over 2 cubed would be 8. That's 8 there. Let's go over 3 cubed is 9. So I can go over 3, down 3. I get a function that looks something like this. So then I'll go a third up. And then 1, 2, 3, 1, 2, 3, and then 2, 3. So it'd be like roughly something like this is your best ability, right? So gives you that reflection over the x-axis and everything. Alrighty. Do. Ah, that's what I messed up on. Since it's a horizontal, I'm over here trying to adjust the y. It's adjusting the x. I was wondering why my graph didn't look the same. All right, so in this case, I would typically go over 1, and then instead of going to 1, I actually need to go to 3. And same concept over here because I'm adjusting the x value. So it'd be like 1/3, 2/3, and then this would be where it was at 3. And so then I would have more of a function that looks something like this. There you go. That's a little bit better. And I think I forgot to do the domain and range of the previous one. So this right here, the domain, at the end is all real numbers, no restriction with polynomial functions. But the range, I can see the bottom is going to be -3. And then the top is infinity. And then over here, the domain and range is all real numbers because there's no restrictions at all. All righty. So I think that's a good on those. And then there's a couple of questions where like it gives you the transformations and then it wants you to graph it. Oh, no, sorry, not graph it, write the formula. So let's look at number 54. So it says use the function g of x equals the square root of x. And I want you to reflect the function across the y-axis. That means there's going to be a negative inside. And then reflection across the y-axis and move it down 3. So that means I need to subtract 3 on the outside. And that's it. Then you look at 56, starting with the parent function g of x equals the absolute value of x. It says move the function 7 units to the left. So that means I need to add 7 inside the parentheses, reflect across the x-axis. So that tells me a negative on the outside of parentheses, and reflect across the y-axis. So then I need a negative inside the parentheses. And that would be it. So it's a lot quicker to get the description and be able to plug it in once you know what everything is being applied to. Right, and then that's pretty much all that I saw in y'all's homework that would give you any complications. But as always, if you have any questions, email me, and then I'll see you in the next video. Bye for now.